Hi, my name is Martin Phan, and I'm a field CTO here at CloudCasa. And in this demo, I'll be showing you how to use CloudCasa's Terraform provider to automatically provision CloudCasa resources like clusters, backup jobs, backup policies, and object storage destinations through Terraform. Let's say you've just deployed a Kubernetes cluster and you want to have it immediately registered to CloudCasa so that you can install the agent, define a backup job, and associate it to a policy as well as a backup destination. And you can use Terraform to deploy and track the state of these CloudCasa resources when you deploy your data protection strategy as code. The first thing that you'll need to do is grab the provider, which you can find at registry.terraform.io. Do a search here for CloudCasa to see the documentation for installing the provider and configuring the CloudCasa resources. Here, under the documentation tab, you'll see the different Terraform resources that can be deployed, from clusters to backup jobs, object storage destinations, and policies or schedules. And we'll copy the provider statement here to our Terraform configuration file, which will end in a .tf extension. So let's jump to our Kubernetes cluster that we just deployed, and you can see here that I'm running some applications that I would like to back up. I'll create the Terraform configuration file using the .tf extension, and this .tf file needs to be in the current working directory from which you're going to run your Terraform commands. So we'll copy and paste the provider statement from the documentation into this file, along with the API token that you're going to receive from the CloudCasa UI. And you can reference the tutorial video on CloudCasa's REST API and generating that token through the link in the description below. Note here, if you're using the self-hosted version of CloudCasa, you'll need to specify the CloudCasa URL for your CloudCasa server, and also specify if you'd like to allow insecure TLS connections to your CloudCasa server. We can save out our file here and now open another command prompt window for applying our Terraform configuration. In my demo, I'm running Terraform 1.11, but any version above 1.10 would be supported. You'll need to ensure that your kubeconfig environment variable is also set so that Terraform will be able to communicate with the cluster. Here, I'll run Terraform init to initialize the CloudCasa Terraform provider, and once it's been successfully initialized, I can then create CloudCasa objects using the Terraform provider. So let's configure a kube cluster first. I'll add a resource definition for CloudCasa_kube cluster and have it automatically install the agent to the cluster. Here you can see some different examples of registering Kubernetes cluster with the provided syntax specifying the name of the resource, the name associated in Terraform, and the name as it's going to be defined in CloudCasa. And we'll just copy the first example in our Terraform configuration file, and I've modified mine so that the Terraform name will be Terraform-kube cluster, and the object defined in CloudCasa will be TF-kube cluster. I can now apply the Terraform configuration by running Terraform apply and reviewing the changes that Terraform will perform. So I can see here that I received an error and to please provide proper credentials, so just make sure that you have the correct API token. And we'll run that command again. So now you can see here that it's creating my kube cluster resource, and if I jump back into the UI, I can see that there's a new cluster resource called TF-kube cluster, and an agent has been automatically installed on it, and the cluster is now in an active state. But now I want to go a few steps further. I want to create a backup job for this cluster and have it run on a schedule, so I can create a Terraform resource of kube backup. And here I can use the previous cluster resource that I just created to retrieve the cluster ID as one of the parameters. You may recognize some of these parameters through the UI, such as selecting namespaces, performing copies, and such. But here, if I don't explicitly add a policy ID, I'll need to have a run on apply parameter set to true in order for CloudCasa to create the backup job. And while we're here, we'll also add a kube policy resource as well to create a schedule that we can apply to this backup job later on. You can see here that the schedule is defined to run at 12:30 every Monday and Friday based off the cron spec, and we'll name this Terraform every Monday and Friday and save the configuration file. We'll execute our Terraform apply statement again, and Terraform apply will create the key backup and policy resources here, showing the plan to add both those additional resources. So we'll type in yes to continue and create those resources. So here you can see that the agent has been installed underneath the namespace CloudCasa-IO. Jumping back to the UI, you'll see that the backup job is created from Terraform and currently in a running state. Also, looking at the list of policies, you can see the new policy created from Terraform with the schedule specified from the configuration. Once you're done with the infrastructure and would like to tear it down, you can use Terraform destroy to delete the very resources that we created from Terraform. Once deleted, you can see the cluster, the policy, and the job definition have all been deleted from CloudCasa. So whether you're an end user looking to further automate your deployment or an MSP looking to provision many environments through infrastructure as code, CloudCasa's Terraform provider can help you with getting your clusters and backup configuration up and running with minimal effort. Deploy your clusters and then immediately assign them to run backups and then tear it all down when they're no longer needed. I hope you enjoyed the video, and if you have any questions, feel free to visit our website at cloudcasa.io. Thanks for watching, and I'll see you in the next video.